All right, today we are diving into something really mind-bending, a totally new definition of life. And this one, it doesn't come from a biology textbook. Nope. It comes from the basic laws of physics. It's an idea that was born from thinking about the absolute coldest, darkest places in our galaxy. And honestly, it could completely change the way you see, well, everything. You know, we tend to think of life as something that absolutely needs the warmth and light of a sun, just like us here on Earth. But what if that's just our cosmic bias talking? This one single question right here challenges our most fundamental assumptions. It forces us to wonder if there's a universe just teeming with life in places we've never even bothered to look.
So here's where our old definition of life really starts to fall apart. Rogue planets. These are whole worlds just drifting through the blackness of interstellar space, completely untethered from any star. All our familiar rules about habitable zones and liquid water they don't apply out there. These dark wanderers are basically forcing us to find a much more universal principle for what it even means to be alive.
To build that truly universal definition, we have to do a little thought experiment. We need to mentally strip away everything we associate with life here on our own planet and just see what's left at the very end. We've got to get down to the absolute bare bones fundamentals.
First thing to go, our reliance on light. I mean, think about it. Photosynthesis is just one possible engine for life, right? And it's powered by a star. But planets can have all sorts of other engines, like the internal heat churning away in their core. So starlight isn't the real requirement. A persistent energy source is.
Okay, next on the chopping block is the need for a cozy surface with an atmosphere. Why? Because life could be thriving deep, deep beneath the ice of a rogue planet, swimming around in a subsurface ocean that's kept warm by geothermal vents. The surface isn't the only show in town. The deep interior of a planet could work just as well. And now for the biggest leap. Seriously, this is a big one. We have to move past biology itself. Yeah, I know, carbon-based chemistry is all we've ever known, but it might not be the only way to build life. To find a rule that works everywhere in the cosmos, we need a principle that's not based in messy chemistry, but in the clean, elegant laws of physics. So this brings us to our new foundation, thermodynamics, specifically a concept called entropy. The easiest way to think of entropy is as the universe's unstoppable mission to spread energy out, to go from hot, concentrated spots to a cold, uniform, and kind of boring state. So the big question is, what if life isn't fighting this process? What if life is actually one of its most powerful tools? Okay, so here it is, our new physics-based definition. A process that arises wherever persistent energy gradients allow matter to temporarily store information in ways that accelerate overall entropy production. Whoa, okay, that sounds like a mouthful, right? Let's just break it down. Energy gradients. That's just a fancy way of saying there's a flow of energy, like heat moving from a planet's hot core out into cold space. And storing information? That's just creating complex, ordered patterns. Think about DNA, or a crystal, or even something as simple as a whirlpool in a stream. That's all stored information. And the implication here is just profound. It means life isn't some special, magical thing. It's simply a mode of behavior that matter can fall into when the conditions are right. Just like how water can be a solid, a liquid, or a gas. The universe doesn't suddenly switch on life. Life is just a natural thing that happens because of physics. Now, this kind of structure, this life mode, it only seems to pop up in a kind of Goldilocks zone of energy flow. If the energy gradient is too weak, well, nothing interesting happens. If it's way too strong, any structure that tries to form gets immediately blasted apart. But right in that sweet spot, that sustained, moderate, middle ground, like the gentle heat radiating from a planet's core, that's where complex, information-storing patterns get a chance to form and actually stick around. This quote just nails it perfectly. Life creates order locally. It builds complicated things, which really seems like it's fighting against entropy. But that very complexity is an incredibly efficient way to burn through energy and increase disorder or entropy globally. It's kind of like building a really elaborate sandcastle. You create all this temporary order just so the tide can come in, wash it away, and make an even bigger splash. So if life is really just a process for increasing entropy, well, it doesn't have to follow just one script. From a physics point of view, there could be totally different strategies for getting the job done. And this leads us to two fundamentally different modes of existence.
On one side, you've got loud life, which is us here on Earth. We're bathed in the high-energy fire hose of our sun, and that drives super fast evolution and makes us really, really visible. But on the other side, you could have quiet life, say on a rogue planet. It would be driven by a low, steady trickle of energy. It would evolve incredibly slowly, sure, but it could persist for billions of years, and it would be almost completely invisible to us.
And this just completely reframes the whole search for extraterrestrial life, doesn't it? We've been scanning the skies for loud life, things like radio signals and weird stuff in atmospheres, because that's all we know how to look for. But what if the universe is actually full of this quiet life? What if our belief that life is rare is just an illusion created by the fact that our senses can only pick up the bright, noisy stuff? The implications here are just staggering. Astronomers think rogue planets might actually outnumber stars in our galaxy. If that's true, then the conditions for this quiet, persistent form of life could be the most common type of environment in the entire galaxy. Life might not be some rare miracle. It could be the default state of matter out there in the dark. So, what role do these dark worlds actually play in the grand scheme of things? Well, they're not just cosmic oddballs. They could be the galaxy's hard drive, a stable background layer where information can be stored and processed over absolutely immense timescales, operating in a sort of cosmic maintenance mode. I love this metaphor. It says it all. Life around stars like ours is a sprint. It's fast, it's furious, and it's bright. But life on a rogue planet, that's a marathon. It's slow, it's steady, and it's continuous. Both are serving the same ultimate physical purpose. They're just doing it on wildly different timescales. Okay, let's put all these pieces together now. We started with a problem, this puzzle about life in the dark, and we ended up with a brand new definition of life that's based entirely on physics. And it all culminates in one final, really profound idea. This is the ultimate takeaway. The complexity of life is a form of memory. It's a temporary recording of information written onto the fabric of the universe. Star-based life, like ours, is a fleeting memory, written and erased in a cosmic blink. But life in the dark? That's where the universe's memory can persist for eons. It's like a slow thought, unfolding across the entire galaxy. And so, when you look at it from the cold, impartial perspective of physics, the winning strategy isn't to be the brightest or the fastest, it's to be the one that lasts. In the grand cosmic scheme of things, persistence is the trait that truly matters. And that leaves us with one last, kind of haunting thought, doesn't it? We have always looked to the light for signs of life. But what if persistence is the real key, the true measure of success in this universe? If that's the case, maybe we've been looking in the wrong direction this whole time. Maybe, just maybe, the most profoundly alive places in our entire galaxy are the ones that are completely, utterly dark.